Hi, hey everybody. Thank you so much for being here on the last session, on the last day of Unite. I know a lot of you would probably rather be taking a nap right now, so I really appreciate you coming out. I'm Timoni West. I'm the Director of XR Research at Unity Labs, and I have with me some colleagues also from the Labs team. We're going to have Charles Migos, who's Director of UX Research, Andrew Maneri, who's the backend lead on Project Mars, and Kyle Vaidyanathan. Did I say it right? All right, cool, excellent. Who's one of our engineers and actually was formerly an intern, so plug for the intern program as well. Okay, so today we're going to be talking about just a subset of everything that we do at Labs. These are the major buckets, and a lot of the projects that we work on fall into start in the left-hand side and then end up becoming things on the right-hand side. So artificial intelligence, we use that for things like animation planners. Machine learning is used in pretty much every sort of aspect that you can think of. And spatial computing, which is our bread and butter and what we'll be talking about today, influences things like authoring tools that we make now and then also what Unity is going to be like in the future. So that is what we're going to be talking about now. Just a quick overview of the tools that we have either made in the past or are making now. Editor XR is an open source extension that you can download on GitHub today that lets you be in the scene view, in edit mode, in stereo mode, actually editing the world as you make it. We made a prototype called Animate VR that lets you actually edit motion splines when you're in VR. Carte Blanche was a prototype of a consumer product that lets you make a world in a game-like environment. We came up with something called AR View, and other people have done this as well, but it basically uses mobile AR as a window into virtual reality, which we think is a really great use case for augmented reality, and you can do with almost any networked Unity game. Wireframe for Magic Leap, that's just a tool we made so we could start sketching out UI when you're actually on the device, really handy. And then the big one we're talking about today, Project Mars, Mixed and Augmented Reality Studio, which lets you create flexible, responsive design for the real world. And that will be what these three will be talking about. Before we dig in, though, I want to explain a little bit about what we mean when we say spatial computing, because there's a lot of words and terminology that are going out right now. And there are different use cases for both, too, and they both have their strengths and weaknesses. So for virtual reality, this is a digital world where you have full control and the computer knows everything that is happening in the space, right? The computer is what is rendering everything that you are seeing. You got a monitor strapped to your head. It is great for putting you outside of your own real reality. It's fantastic. I think, a lot of people say, what's the killer app for VR? Honestly, I feel like creation tools are already 90% there. Like Tilt-Brush is awesome, and Medium is awesome, and people are making really robust worlds already in virtual reality. It has some downsides, like if you're in the same space with someone else who's in virtual reality, you better hope your tracking doesn't cut out or you two are going to headbutt. And it's not as intuitive as you'd think. We definitely learned a lot of hard lessons when we were making Editor XR because we thought it was going to be so easy for you to be in your game, actually making the game. And then it turns out humans aren't used to moving like large-scale buildings 1 inch, so we have to figure out ways around it. So for mixed and augmented reality, it's kind of the inverse, right? Where previously the computer knew everything in virtual reality. In augmented reality, the computer doesn't know anything about the real world other than what you give it. And depending on the device that you're using or what you've got strapped to your head, it might know very little about the world, all the way down to just a single plane. It is great, though, for adding all of the digital stuff that you want to your current reality. And we think, like, long-term, this is going to be how computers are in the future, which is why we think it's so important. We think that the little windows of phones are just a step towards a more robust computer-human interactive experience where it's more natural and it's not just this sort of like small window into the digital world. Calibration is a huge problem. We'll dig into that in a little bit. Frankly, the hardware is not quite as far along. Like when you think about augmented reality and your dream of it, the reality of what's on the market or pre-market today probably does not actually fit into what you're dreaming of. Virtual reality is a little bit closer to what we finally want. And much like virtual reality, but even more so, it is really not intuitive compared to what you think you'd be able to do. The reality of what you can do with augmented reality. It's exciting that what we think of as intuitive is not right insofar as we can then do things we had never dreamed of, but it makes it complicated in the meantime when you're trying to make experiences that people understand immediately. Oops. And just As a quick review, most of you, actually I should have asked this before, who's working in augmented reality right now? Like almost everyone. So this is no surprise, but just a quick reminder, this is how computers make sense pretty much in the world today. If you're doing anything with any kind of augmented reality hardware, it has at least one of the things on this list, and hopefully almost all of them. And the more information you have, the better their experience will be. But aside from all of the incredible technical hurdles and manufacturing hurdles and optics hurdles and processing hurdles, there's some other big challenges when it comes to us actually building out the spatial computing future of our dreams. For one thing, digital objects right now are described and displayed and rendered in very specific ways. Usually they're part of a larger executable. There is no way to just take this and pretend this is like a digital version of something. There's no way for me to just throw this at Kyle and have him catch it if we're both wearing AR glasses, unless we're both running the same app at the same time. And this is not sustainable when it comes to augmented reality. We're going to need to be able to quickly download digital objects independently of these large apps. The way that you share information today involves multiple apps. If I want to send you a link, I will have to get your email, I have to open my email app, have to open the browser, have to copy and paste, have to send it off, and then you have to open up the browser. Again, this isn't sustainable if we want to start treating digital objects more like physical objects. And I think this means we're going to have to start having persistent identities that are digital, but not necessarily tied to a platform. So today, you can find me on Facebook, you can find me on LinkedIn, you can find me on Twitter, but the reality is I have to go in and reset all of these permissions every single time. And when it comes to spatial computing, permissions are going to be paramount. We're going to have to define where you can see things and why and when and who owns it, right? Oops, I missed a slide, sorry. So we're going to have permissions that come with the individual and can go into all of these different, both like physical spaces, but then also from app to app or from experience to experience. We're also going to need to give users the ability to customize a lot more. Like you get to define and decide everything in your house. Well, maybe you do. Maybe someone else does in your house. But in general, no one else is like, yeah, Apple is not coming into your house and saying, you only can have a rug like this, and the rug has to be this size. They can do that right now with your iPhone. You can't customize what the icons look like. But when it comes to having a computer in your home that is personalized and ubiquitous and part of you, we're going to need to let users do what they want to do with it, a lot more than we're doing today. We're also going to need to talk to our computers a lot more and tell them things like, no, please don't play this ad above my bed, or no, never, ever, ever have like Nazi graffiti in the bathroom, like no, lots of stuff that you don't even have to think about today. We're going to have to start articulating. Some of it might be a little bit uncomfortable. You have to have a conversation with your roommate about when you can see the art or when it starts playing music, and is it public or is it private? So a lot of new conversations that'll be happening. And then finally, just things like controllers and inputs and all that stuff. We're working with game controllers right now. Over the next 20 to 40 years, that will certainly shift. My guess is it'll get a lot more customized as electronics get cheaper, but we don't know. So this is the future. This is what we're thinking about. So what we are doing about all of these problems is we are trying to make tools that make sense of all of the varied data that I showed earlier, all of the ways that computers can think about and describe the real world. We're also thinking about things like the permission states that I mentioned, what are developers going to need to make an experience that works well in any bedroom with any type of user who wants to share it with another user who has a completely different permission set and hardware stack. What do we need to build as Unity in order to make sure that you, the developers, don't have to think about that and do it again from scratch every single time? We talked to a lot of companies about how they're thinking about this too, because we know we can't do it alone. I mean, obviously it's cool that Unity is a central location and you could build it in Unity and it goes everywhere, but if everyone else doesn't support or think about this the way we are, it's not going to work either. So, but in general, we're trying to be really thoughtful about this, and that is the key. So I know most of you raised your hand, you're working in AR, and if you're interested in this, please, seriously, just email us if you want to keep the conversation going. If you're in San Francisco, we love having people over for lunch, so we'd love to hear and talk from you. But now we're going to jump into more about Mars, and Charles Migos is going to take the stage to talk about the design process.
All right, so that's quite a picture that Timoni just painted for us. It's a rather all-encompassing viewpoint of what AR means for us as we're on the dawn of kind of a new medium. So the daunting question is, How does this clicker work? That's the daunting question. There we go. Where do we begin? Well, we're not starting from scratch. Like, we have a track record of building tools in advance of the emergence of the medium. Editor XR is a great example of that, where you're able to kind of edit and craft the art directly in a head-mounted display. And that's awesome. And that was always done with foresight to the world of mixed reality, where these things would eventually converge. But while we're waiting for that world to catch up with us, we're busy doing concept pieces like this one. So this shows kind of a world where you can take a banal, benign object like a business card and transform it into something which is kind of much more. Now, you can be a true believer in a world where business cards have superpowers, or you might not be. It doesn't matter. This concept really just served for us to kind of like identify the technologies that we knew we would be working with and bring them together in ways that made sense. So I'm going to stop this video here and show you the same video, right, that identifies just that, right? So here we're doing object detection, segmentation, sub-segmentation within the object, hand tracking, eye gaze tracking. All of these things are actually parts of our available technology tool set today. They're just not brought together in a device that gives us all of this capability kind of in one place, in one-stop shop, although we're getting daringly close to that right now. And that's why it's such an exciting time. And of course, we create tools. So why not take a look at perhaps the creation environment of the future, which is itself augmented reality. Of note here is the fact that this is spatial computing without a computer. Crazy? Timoni likes that when I say that, yeah. And here's another example where we have a device like an iPad, which is also affording the ability to edit character animations and sequence things and have the augmented reality preview. So some of this does feel pretty futurist in nature, but it's all done, how would I say, like intentfully. Like we are trying to purposely build the tools that we're all going to need as we move into the future. So that's my segue into, all right, what are the practical realities? At the outset of every process for design, we look at key scenarios that sort of are representative of what people are trying to do in the real world. So one of those examples that we focused on was the classic museum scenario, which feels like it might be getting a little long in the tooth, but still is a great example of what people are trying to do today, and so we adhered to it. But if you take a note of the actual drawing date in the bottom left-hand corner, you see that's from 2012. That's how long we've been thinking about this stuff. This is a little bit futurist in that it invites the attendee to a museum to pick a spheral-like miniature robot, to drop that robot on the floor, and then be guided throughout the museum. And as we were thinking about the crafting of this scenario, we weren't thinking about a developer profile exactly, although that's the most important profile to us. We were rather thinking about how do we enable this kind of experience to be created by a museum curator or a docent, or at least a creative agency that might be working for them as they want to build this kind of experience into their museum. And then in the final frame here, you see we have a digital avatar. Of all of this, this is the stuff that we're delivering in Mars. You were capable of rendering stuff like this or achieving stuff like this with the tool set that we're providing very soon. In this other example, also taken from the museum scenario, the designer here was envisioning, okay, well, how do we make sure that we can get to the right level of detail around a museum piece, here in the case of Mona Lisa, call out the features that the docent wants you to pay careful attention to because there's some important historical fact or context that they want to point out to you. And in this case, they're showing that, okay, this crack that was introduced as Mona Lisa was being transferred from one frame to another being an example of that. So this is our favorite statement in the Mars team, right? Reality is our build target. But what does that mean? Apart from being pithy and cool, to say what it's really about are these four concepts right here. First and foremost, deal in real-world units. We want to have high correspondence between real-world and virtual content. The only way to guarantee that is by using real-world units. The second thing is contextual authoring. So even when you're working in the editor, you're working towards a reality that you can see, and it's being visualized, telegraphed towards that eventuality. The next one is probably the most important thing within Mars in terms of features. It's queries and conditions. This is literally the glue that binds the virtual to the real. and I'll explain more about that in a bit. Semantics too. So right now we can say with some confidence that a floor is a floor and that a wall is a wall, but we're very near the point where providers and the platforms will be giving us much richer semantic information so we can identify common objects like tables and chairs, et cetera. And we're building that into the tool set today. So when those things come online, they'll be accessible to you. All right, so if you had a chance to watch the keynote from the Berlin Unite in July of this year, you got a great preview of Mars. If you haven't seen it, I highly encourage that you go take a look at it because it gives you a really comprehensive view of the tool in action. I'm not going to do that here for you today. Rather, what I'm going to do is call out within this screenshot the two key elements of Mars, right? One is the scene view. It's the scene view as we know and love it today in the editor. But it's a little bit different. You're not actually doing composition in that view. Rather, you're setting up elements in that view. The composition happens in an automated way in the simulation view. So here you can see the dropship is having its query be edited, and as a result of that edit, the dropship is appearing happily on a simulated bed in a bedroom. These are what the query gizmos kind of look like. We're trying to make them feel very friendly and have them speak to their application. So in no particular order, except from left to right, the first one is basically a surface area constraint. You're setting a minimum and a maximum surface area side for an object to kind of manifest upon it. The second one is the elevation constraint. So if you want something to appear only on a surface that stands about this high, because that's where the goal of your game is, you can set that up very, very easily. And then finally, we have the angle control. If you need a very specific orientation for a surface to get correspondence with other surfaces that are important to you for your game or whatever context, you can do that there. It doesn't end there. We've got a bunch of other constraints that you can add as components to any Mars entity. So you can add geofencing, you can add marker image conditions, a whole host of things beyond these things here. All right, so here we have a video of the demo content that we put together for Unite Berlin. Sort of happening, and I'm not showing you this because I want to blow your minds with procedural terrain building or gameplay. That's not the point of this. So here you can see that two queries have been satisfied. We have the player character kind of spawning on one piece of terrain, and she's free to kind of move about the world. Cool. The reason that I'm showing you this is because I myself have built this demo in about an hour. I was able to kind of proof it, build it through Xcode, get it up and running. I'm a designer. I'm not as smart as you people. The hardest part of that for me was getting my third-party controller, which I downloaded to make the character move, work. And I had to get some troubleshooting help from my colleagues over here to make that work. And that was the longest part of the process. You can literally do it in minutes. I say that with certainty. All right, so we've been busy dog fooding our own product, and we have been refining the design. So this is what you can expect to see when Mars is released to you. So of note here is that panel that sits just to the left of the scene view. Is it my right or your left? Yeah, left. It's the left of the scene view. And in it, we've sort of consolidated all of the augmented reality tools, so it's really a one-stop shop. You can find everything easily at hand. In the first panel here, you can see that we have the constraints tool that I described to you that appears in that top panel. We have also handily given you the world scale control. If you've been building these kinds of experiences before, you know how important that is, and you never know you need it till you need it, and so we want to make sure it's easily accessible. In the bottom part of the panel, in the bottom part of the panel, you can see that we have a thumbnail view of the simulation view. It is a dynamic thing, so whenever you edit queries or you add content, if those queries are being satisfied, they'll end up here. You can see that there's a little list beneath the actual simulation view, and that shows all of the queries that you've defined thus far. The ones that are brightly color-coded have been satisfied, they're met, they're appearing in the view. That one that is in red is indicating that no, I haven't found a surface based on the constraints that you've set, so the content's not appearing. And it gets even better because if you hit this magical toggle switch, you can basically update the whole of the scene view to your simulation view. This is a fully flexible layout, so you can put it wherever you want. It will adapt to whatever your workflow is and your preferred layout for the editor. But here what happens is you're not only previewing the content, you can continue to edit and build right against it. You can drag things out of the library onto a surface that doesn't have a query, automatically generate a query. You can troubleshoot any existing query. You can edit those queries all in place. So you're making decisions very rapidly, and the iterative cycles are very, very small. Aha. What I should have said before I left that slide was, okay, so what's next? We've given you like a verifiable facsimile of the real world directly in the editor. I think you can all appreciate how it really aids in the content creation process, in the development process. So what's next? And then I would have clicked to the slide, and I would have said, build in the real world, right? Because we have these devices, these very powerful computing devices in our pocket that are all AR capable. And there's nothing more convenient than the thing that you already have in hand when you encounter a real world context that you need to record in some measure. We talked to a lot of people in the design of Mars as doing part of the research phase. And a lot of them are doing site-specific or location-specific installations. And they need the data from those locations to get into the editor such that they can build something which is as great as they imagine it can be. So we're building for you all exactly that, a companion app that will allow you to kind of go wherever you need to go, record the data, and start to build and stub out and block out where content's going to appear, and in addition to recording all of the valuable data that's in the real world for you. So up next is a concept video. So here you see like starting room scanning process, a floor has been identified, some surfaces are starting to be discovered. That's all great. And when you find one that you like, you're like, yes, my game is all about a coffee table. You can turn that into a query very quickly. And beyond that, you can start to edit the constraints, like that's my minimum coffee table size, what have you. And then you can start to add content. This syncs with your project in the editor. You can retrieve assets from the project in the editor and place it wherever you'd like. And in the second video, we're showing, oh, it is not audible. I apologize. This is all me. Can I even get over there? Anyone see my cursor? There it is. Okay, sorry about that. So here you can very quickly go ahead and create an image marker. Now, an image marker is just a query that has an image target constraint applied to it. But here we're giving the ability to kind of create one in a very easy process and then do things like identify those hotspots. Remember the call-outs in that Mona Lisa example that I showed you earlier? This is how you can craft them. All right, so that's a glimpse for around the Mars toolset, where we're going, what you can expect to see in the near future. I hope you like it. We're building it for you, and we're excited to build the future together with you. And with that, I'll introduce my good friend, Kyle.
Thank you.
I'm trying to introduce my good friend, Kyle. What's happening here? Here, I'll just do this. Okay.
Cool. Hey, everyone. Thanks for coming. So what I'm going to talk about is what I've been calling virtual AR, which is a fun way of saying that we can simulate AR in a virtual space. And Charles talked about that a bit, and it's been my pleasure to kind of work on how do we integrate that in the editor and kind of dealing with all the interesting things you come across when you work on this. So in an ideal world, you would want to test your app on your device, right? That's what you would think. There's nothing quite like being on the target hardware. But in reality, you know, that's not quite right. That's not always the best thing, and it doesn't always work out. If you're a mobile developer, you are very familiar with this first thing, which is that iterating and building to the device is slower than you would like. And there's effort being put to make that better. But it's not always enough. And if you talk about 2 and 3 here, debugging on the remote is sometimes insufficient, or maybe you just don't have enough devices in your office. And then the last one is the one that's AR specific, which is that AR reacts to your environment, and if you're testing in your office, that's just one environment. So what you assume about how your app works is misleading, because you're biasing everything you've done based on maybe your living room at home and maybe your office. So the first thing you want to do is maybe obvious to you guys, but keep things that are purely virtual testable in the editor. Play mode in the editor is your friend, even in AR. I think it's really important to have mouse and keyboard controls to fly your camera around, because if you are building to the device just to find out that you forgot a reference or something, that you're wasting a lot of time. So maybe that's obvious. But can we do better than play mode? Because as some of you guys know, when you go into play mode, everything plays. It creates things. It destroys things. It doesn't save any changes you make, and when you exit play mode, everything goes back to where it was before. So the interesting thing is with Mars, we have a reality and we have your conditions, and that layout, that initial layout of where everything's going to go, can be evaluated really fast, faster than going into play mode. And so you can actually edit and simulate at the same time. It's sort of semi-play mode. So you see that the environment is a virtual scene that for now we've just crafted with some assets, and we have simulated copies of all of your AR objects. And then at the bottom there is your normal runtime build scene. You know, that fake kitchen is not going to go into your app, obviously. And the cool thing about this is that the way we're doing it, we're not changing your scene. Your scene doesn't get modified. If something happens in the simulation, we're not going to accidentally move your assets around. Your scene view stays as you created it. So while working on this, one thing we have come to realize is that you really want to simulate the data and understand how the device is seeing the world. Imagine the case where you have a ladder from the floor up to the edge of the table. You might be tempted to say, okay, well, to simulate this, let's just create a transform for the start and a transform for the end and test that my texture stretches properly. But in AR, you're going to realize that you don't have a start point and end point. You have a floor and a surface, and that's a bunch of vertices. And what you actually want to simulate is how did you get the start and end position from that data. And so what we try and do is have simulation providers, whereas in the simulation, all of the data you're getting is going into the database, the same pathways and the same code paths that you would actually have on device. And that gives you a more realistic experience. That being said, you should be very aware of what's unrealistic about your data. If you saw in that kitchen or in any of our mock-ups, we're putting planes on tables, and then if you run on device, you're like, this isn't quite right, because in reality, the devices are imperfect. They're giving you, a polygon that's slightly offset, maybe it's a little bit weird, and you're probably being optimistic when you're simulating. But maybe you shouldn't care. I think this is an interesting way of thinking about it, is that if you're designing for the future, think big. Don't be always held up with things like, okay, let's make an extra script to simulate, the problems with the device. That's a lot of effort, and maybe your problems will be solved in the next version of the hardware anyway. So you shouldn't be afraid to just think big, and as Charles was mentioning, one day you're going to be able to just say, I want a chair, and let someone else figure out the code to make that work, The last most important point is that simulation allows you to test in so many places. Test it in a park, test it anywhere, test it in somebody else's bedroom that they've recorded and sent you the file of. And that's really powerful, and we shouldn't, we shouldn't be building to the device and then walking down the street and testing it. That's obviously going to be a pain and slow process. So that being said, you can only simulate so much. I like to say there's more to life than rearranging furniture. In all of our examples, we're talking about, okay, we're going to put this on a table and this on a wall. But what about reflective surfaces and lighting? And what if a person walks in front of your phone? And what if there's drift? And, all those things that you can't really think of. You might be tempted to say, well, we just got to get more realistic simulations. You got to get in VR. You've got to have physically based rendering. You've got to emulate the device. But that's probably overkill, right? And even if you could do all of that, there's no simulation of the human brain yet. You're never going to replace the experience of giving it to someone who hasn't used it before and seeing how they really interact with it. So that's sort of always going to be the limit to what you can simulate. So what's next? The first thing that you probably are thinking about is that scanning and having an AR experience doesn't happen all at once. You don't scan the room and then say start. You could design your app to do that, but that's kind of giving up. Really, you want the app to unfold as the person starts using it immediately. And we want to be able to simulate that. So we're working on ways to sort of have encoded the information of what order do you find the data in and how did it come out that way. We sort of had to do a first special case for that when we were doing face masks, because we wanted to simulate the mask reacting to your face live. The second obvious ask is to record data. Everything you saw was been hand-authored environments, but as Charles already mentioned, we're working on that app so that you can get real environments. And the last point is automation, which maybe you didn't think of, but we realized that it's going to be kind of simple to just take, say, 500 bedrooms and run your app. You don't even have to look at it, and it just gives you a report that's saying, in 50% of the rooms, your app failed to find a valid layout, and that's useful information that can save you a lot of time. So with that, I'm going to hand it off to Andrew. Thank you.
Thank you, Kyle. So how many people have got to watch the Unite Berlin keynote? Seen a few people here. All right, well, I'm going to be showing some little behind-the-scenes mock-ups of some of the things we made for that. But first, I want to talk about this phrase, co-designed by the world. And what it means is that you're making world-aware content, and when you're doing that, the world has a say in how your content looks. So here are 3 diagrams that we made when we were developing the Unite Berlin Mars demo. And what I want to call out here is that it's more about how the environment is laid out than the content on it, and that's actually a bad thing. It's showing how green we were at the time for producing AR content. When you're making AR, or when you're blazing new ground, there are times you have to learn things the hard way, and that's what we did. Thankfully, you don't have to. We're going to share some of the critical lessons that we've learned about making world-aware content. And really, in short, it's about where to focus. So if you've made any kind of mobile AR app, you've probably seen those helpful debug planes that show up as you're scanning a scene. And while they have a definite debug look to them, they also provide a critical feature in that the user knows exactly what data and where the data is coming from. When we've turned it off, we found that it takes away a critical path of communication about what your device is doing. When we decided to turn off the debug planes for our stage demo to polish it up, it meant we were essentially running blind, and that was a big problem because we didn't know if and when the tables had been scanned incorrectly. So I would say in that case, just make them look better if that's your concern. So show everything that your hardware and app is doing behind the scenes. If you're reserving a plane, change its color. Display the point cloud as it gets read in. If you're locking data, show that too. All of this data visualization looks really cool. There will be a point one day when everything is mundane and functional and this doesn't matter anymore, but that's not the case yet. The other critical point here is that because the user can clearly see what's happening, they'll also know what to blame when your app isn't working. So if it's hardware or CV library or your app, it's good to know this, especially if you're getting bug reports, then they can give you something other than the content isn't showing up. It can be like, okay, well, it's not seeing my table, it's not seeing my wall. Here's one of the Berlin mocks again, and it shows a very deliberate setup of 2 tables of a specific size, distance, and orientation. It even shows where the users and the assistants are standing. And what you can take from this is that you can spend a whole lot of time making content look great for this exact setup, and you're going to find that nobody has this exact arrangement of furniture in real life. Even more likely, you're going to find that the device that's scanning in isn't reading in data the way you expect. So it doesn't matter if this is laid out the same way, you're not going to get it. One example is that plane alignment really doesn't mean anything to ARKit and Core, and I don't mean the difference between like horizontal or vertical planes. I mean like it's going to decide that your table's oriented like diagonally or something like that. Even more importantly, like if you're dealing with an unevenly sized surface, like it's shaped like a C or something, then alignment really doesn't make any sense. So you don't have like an X or Y plane to author against. So don't spend your time making content look great for one setup. Spend your time making content work in as many setups as possible. Make it as dynamic as you can. When you do this, your focus switches to making apps that are robust and against the unpredictable nature of the world. This actually ends up being flashier as well because it makes your app seem like it has a sort of built-in intelligence to handle any odd environment your user can throw at it. In fact, it does. So here's a newer mockup I made with this sort of dynamic flexibility in mind. And in here, all of the environment pieces are dynamic. So like you can see like there's a table, like in the first slide, there's a table and there's all this sort of environment around the edges. And then when actual bridges connected for gameplay purposes, all of the environment is actually cleared away. This is subtractive authoring, and this is the easiest way to author something quickly in AR that can handle lots of different, all the dynamic flexibility. And as an added bonus, you're no longer constrained to like a single surface or a single pair of surfaces. Everything can start being hooked together. And this extends into another way as well. We have a feature in Mars where you can just author for like the largest possible surface you want, and then as you get a smaller table, things on the outside of the bounds just start getting culled away. This sounds really simple, but it also means you have to be mindful of where critical content goes. Or what I'd recommend is shifting to a system of decorating your environment with critical points. So like here are all these different locations that a player could spawn. And then the nice thing is that you can actually add a query to your application that says, well, give me the spawn point closest to the user to put the player and the spawn point furthest away for the gameplay goal. So once people are using and interacting with your AR content, it's best to not change it under their nose. This means that once you've read in a plane or other surface and used it for content, leave it alone. Ignore the updates, at least while the user is looking at it. This also tends to reduce bugs. Environment is usually treated as fairly static in games, and trying to change it while it's being interacted with leads to really bizarre edge cases in any kind of app. We find that NavMesh in particular gets really cranky about changing surfaces that things are actively pathing on. Now, this is different than allowing users to interact with the real world. For example, you could have like two armies on a table, and you like put a big book in the way so they can't get to each other, or you can use like a plank to go, like a real world plank to go and make a character have a path. That's a compelling gameplay mechanic, but that's something that you're going to have to evaluate on a case-by-case basis whether you want that in your game, because it can also overshadow what you're trying to convey, or it can give people an avenue for cheating. So the improv concept of yes and is the best philosophy you can take when developing AR content. Users tend to create experiences with this expectation that a table is perfectly clear and clean, and that is highly unusual. Like, this is a picture of my work desk after I've cleaned it up. Clutter is the norm, even if it's a small amount. So use the clutter. It'll give the world you generate a unique character that matches the player's real-world environments. It even adds a fun element of allowing the user to influence the level design in an indirect way. So I said that a subtractive workflow is easiest to author. And while that's true, an additive workflow is the most robust. You're going to end up using both when you're developing AR content that's world-aware. So here's some examples. Here we have like a water bottle on the desk. Well, what should we do with that? Well, we could put a castle in the way. You can touch it, the characters can touch it, it's fine. Same thing, like if you have like books or a keyboard or something on your desk, you could have a hilly environment that covers it up. It's also not all on you. It's up to the supporting hardware and software to recognize the clutter or cluttered objects and surfaces. Right now, if you try to scan this in with phones, you'll only get clean planes. This is something we're actively working on building into Mars, is the concept of a cluttered surface or a cluttered plane where you get a plane with a height map. And it also works in reverse. So one feature we've added to Mars is the ability to write virtual data back into the reality representation. So for example, here we could have like a building that, well, I talked about the spawn point example before, but another example is like these ledges. So we've talked about like building a bridge between two tables, but what you're probably going to have is like a table with like a grassy environment and a table with a snowy environment, and you're going to want to build, and then like a third one with like a desert. And how do you build bridges to all three of them? In Mars, we have this concept of reserving data so that no two things go on the same surface. So in this case, you actually need to expose like ledges you can build to so that you can use that same functionality to actually control who gets what ledge, and then you can start building bridges dynamically between all the content. Another example is like you could just put a virtual table in your scene, and it goes and says, okay, well, here's a surface users can author on. And since it's in the Mars database, if you're looking for a flat surface to put your content on, it'll appear there. By blurring the lines this way, you can start defining how you create and decorate your scene in a much more granular way, and it leads to naturally very adaptive content. So remember how I said don't be too flexible? It doesn't just mean that you can set it and forget it. You still have to make your content adapt after the fact, and that's because you have to be a good AR citizen. So I'm going to paint you a scenario here. A user has been running your environmentally aware game. You've decorated their world beautifully. They've scanned everything in, and you have a clever flow set up. Your character could like start on your bed, and then they have to do a series of jumps up your wall to get to like a goal on top of your bookshelf. Then the user decides that they're just going to go ahead and put their Netflix AR app directly on your wall. Well, guess what? A good AR citizen is going to let that region of space go. Otherwise, neither app is going to work right. User discretion always has priority. And that's just one way that AR is guaranteed to be unpredictable, more than any other medium, and at runtime. It's not likely you'll be able to account for everything that can crop up in the real world, so having good fallbacks and contingencies is critical. This is just a default feature you have to have. You may have to allow teleporting or moving of your content or characters if a real-world wall is occluding a path, for example, if a door just opens. This is sort of the opposite problem you have in VR, where in VR you can just apply infinite force to an object. In AR, the world can apply infinite force to your digital content. So Mars can handle this to a degree. If you're starting to mark critical areas, it can detect if pathing is gone, and then it can go and rearrange your content for you. So what you need to do is you need to identify these features that are necessary for your experience, and then we'll do the rest. Panic button should be a standard feature, at least for now. Time-based fallbacks are another good use case. What to do when a user has been scanning their environment and nothing you need has been located. This might be a time where you need to just stick in a virtual table if they're in a blank room. So I'm going to leave you with the #1 rule for contingencies, and actually this is sort of the golden rule of AR. It's based on the golden rule of engineering, and that's that if your app ever has to make a decision between being functional or obeying the laws of reality, always make it functional. All right, and that's it. Thanks, guys. Do we have time for questions? Cool.
All right. Awesome talk. I love what Unity's doing in the future, and understanding spatial environments is absolutely there. And I see that there's an XR framework for AR Core and AR Kit, and I've seen Magic Leap at this conference. Is there any kind of thoughts about integrating Magic Leap's SDKs, or what other platforms are a challenge or an opportunity for the labs team?
So Mars is being designed specifically as a middleman, so we want all data and providers to come together in Mars. We're providing the intermediary layer, and we want everyone in.
It's beautiful. Thank you. Thank you for everything you're adding to us.
All right, I'm not exactly sure how to ask this question, but I'm going to give it a shot. If you set up an anchor, such as an image, and you start walking away from it, it does a pretty good job of handling drift, I can tell. But is there anything planned or anything happening right now where you can support the position of an image and an image target with the plane, spatial, is there a way to support the image target with the planes? Meaning if you're looking at a wall and you found an image target and you start walking this way, and it knows, for example, that there's a vertical plane there, is there any way to sync the two so that as the further you walk away, your representation is going to stick to that wall better?
Yes. Mars specifically, in our kind of reality database, we use a custom coordinate system. So it's partially on the providers, it's partially on us to keep all of those things in sync. You can also, part of the reason that we have this sort of concept of a Mars entity is that an entity could be described with a plane, or it could be described with an image tracker, it could be described with a model target. All of these things we're supporting. So yeah, the fusion is a little tricky, but it's something that we're handling behind the scenes.
Is that kind of currently working in the foundation stuff, AR Foundation?
We do support the AR Foundation, but if any other sources are coming in, that's on our level.
Okay, so that would be something that's supported by Mars, but not necessarily the stuff that exists now.
Yeah, and it depends on that depends on AR interface's roadmap. So I will leave that for R&D.
Okay, thank you.